We live in an age awash with information. In the realm of deep learning, there's a pervasive belief that the solution to every problem, the key to unlocking superior model performance, is simply more data. It's an intuitive thought. The more examples a model sees, the better it learns. But what if this widespread assumption, this pursuit of an ever larger data deluge, is actually leading us astray, or at least, missing a crucial part of the picture? The truth is often more nuanced than a simple quantity game. While data is undeniably the lifeblood of deep learning, simply accumulating vast amounts of it can often be a costly, time-consuming endeavor with diminishing returns. We find ourselves drowning in datasets, yet our models aren't always performing as spectacularly as the sheer volume might suggest. This paradox highlights a critical misconception, that all data is created equal, or that the sheer weight of numbers can compensate for inherent flaws. It's time to challenge this more is always better mantra and dive deeper. The adage junk in, junk out isn't just a quaint saying, it's a fundamental truth in machine learning. If your training data is noisy, inconsistent, biased, or irrelevant, your sophisticated deep learning model will simply learn to replicate and amplify those imperfections. No matter how complex your neural network architecture, or how advanced your optimization algorithms, poor quality input will invariably lead to poor quality output. It's like trying to bake a gourmet cake with rotten ingredients. So, what constitutes good data for deep learning? It's not just about size. Good data is clean, free from errors, and accurately labeled. It's relevant to the problem you're trying to solve and representative of the real-world scenarios your model will encounter. It's diverse enough to prevent overfitting to specific, narrow examples, yet focused enough to be meaningful. This balance is incredibly delicate and often overlooked in the race to acquire massive datasets. The cost of bad data extends far beyond just a poorly performing model. It wastes computational resources, prolongs training times, and demands significant human effort in debugging and retraining. Engineers spend countless hours trying to fix model inaccuracies that originate not from the algorithm itself, but from the flawed data it was fed. This hidden overhead can cripple projects and significantly delay deployment, making the data deluge less a blessing and more a burden. Instead of solely chasing quantity, we should prioritize diversity and representativeness. A smaller, well-curated dataset that covers a wide range of relevant scenarios and variations can often outperform a much larger dataset filled with redundant, irrelevant, or biased examples. It's about ensuring your model sees the kind of data, not just of data. This allows for more robust generalization and better performance on unseen real-world inputs. This brings us to data cleaning, often considered the most tedious but also the most critical step. Identifying and correcting errors, handling missing values, removing duplicates, and standardizing formats can drastically improve model performance. A meticulously clean dataset, even if smaller, provides a much clearer signal for the deep learning model to learn from, reducing noise and focusing its learning capacity on meaningful patterns. It's the essential groundwork. Another powerful strategy involves maximizing the value of your existing data. This isn't about simply getting data, but about getting in from what you already possess. This thoughtful approach can involve transforming existing features, creating new ones from combinations of existing data points, or cleverly reframing your problem to leverage information more effectively. It's about intelligent design, not just brute force. Hey-race where data augmentation becomes a hero, implicitly demonstrating how to expand your dataset smartly. For image recognition, techniques like rotation, flipping, cropping, or adjusting brightness create new, valid training examples from existing ones. For natural language processing, rephrasing sentences or substituting synonyms can achieve similar effects. This process expands the diversity of your dataset synthetically, without needing to acquire entirely new, often expensive, raw data. Effective deep learning isn't just about throwing data at a problem, it's about strategic data curation. This involves a deliberate process of selecting, pre-processing, and augmenting data to create a dataset that is not only sufficiently large but, more importantly, high quality, diverse, and relevant. It's an iterative process, often requiring domain expertise to understand what truly matters and what introduces unnecessary noise or bias. Crucially, the human in the loop remains indispensable. Automated tools can assist, but human expertise is vital for defining data quality metrics, annotating complex examples, and understanding nuances that algorithms simply cannot grasp. Expert human review helps identify subtle biases, unusual edge cases, and critical data points that a purely quantitative approach might overlook, ensuring the data truly reflects the problem space. In conclusion, the era of the data deluge requires a paradigm shift. We must move beyond the simplistic notion that more data inherently leads to better deep learning models. Instead, our focus should intensely shift towards data quality, thoughtful curation, and intelligent augmentation. By prioritizing clean, diverse, and well-understood datasets, we can unlock the true potential of deep learning, building models that are not just powerful, but also reliable, fair, and truly intelligent.